Okay, does this work? Great. Like Ben said, I'm Jeff Peterson. I recently participated in a news interview in a local station in Idaho Falls, Idaho. You probably have no idea where that's at. I got home, I watched it with my wife, and I said, "What did you think after we got done?" And she looked at me and very seriously said, "You should have smiled." And I thought, great, all that work and that's all I got. But I'm going to try really hard today to smile. So today, there is no technical depth to what I'm going to present to you guys. But really, this is a celebration from my perspective of all the work that you guys have done. So we've taken all of these things that you talked about today and we've tried to put it together into something that's real, that's tangible, and it works. So we're going to just talk about this a little bit today. So an ONT is the device that you see on the side of a home in a fiber network. And traditionally, it's something that just takes the status quo and makes it faster. It doesn't change anything. It just gets it to you quicker, and then you're still stuck with the same problems. So we wanted to come up with a way to solve that problem. So there's a difference between an access network, which is typically where the ONT terminates, and then it goes into the home. And then there's an edge network, which we've kind of talked about today in an indirect kind of way. And we want to extend the network from the access, which is just an extension of the core, all the way to the home. So the core becomes that ONT on the edge. So cloud at the edge is kind of a term that, and it solves that edge problem where we're trying to get stuff out to the customer or out to the subscriber. And how do we do that? And I believe that what you guys have been working on changes that. As we bring it all together, the way things are deployed, managed, and consumed can be different. And it really does change the paradigm of how this stuff works. So fiber to the premise with cloud at the edge and OVS really does change everything. And we're going to demonstrate how that's happened. So this is a quote that I really like, and it's from Scott Shanker. He said, "Everything interesting happens in software at the edge under the control of SDN." And we're going to demonstrate today how that's happened and how that really is changing the way that things happen. So what is cloud at the edge? So we've worked to create something called a virtual broadband gateway. We call it an ONT on steroids because it can do a lot more than just take an optical signal and transmit it into the home. So here's a listing of some of the things that it can do, and I'm not going to spoon feed this to you. You can just read through it, but some of the important things are it's OVS, it's OpenFlow capable, it does virtual machines, it has Linux containers, it can do service function chaining, it can do NFV, it does CPU switching, it has TPM. We'll talk about that a little bit more. And because it's a virtual environment, here's a whole bunch of things that we can do with it, which is really, really cool. So what does it do, really? So it moves control of the network from the core to the edge, which is good for a telco, and the companies that we work with and the people that we work with are telco people. So the things that we're doing and solving for them are very important because, as I think it was Chris mentioned earlier, the world for telcos is changing, and we're trying to help them as that world changes. It also enables multi-tenancy for the service providers. So in one device on the side of the home, we can have multiple service providers. So you can get different things from one thing on the side of your home, and if you want to change providers, it doesn't require a truck roll and someone coming out and digging up your yard or putting something else on the side of your house. And it does create a clear demarcation point between all of the people in the network operator, the service provider, and the subscriber. So everybody has their sandbox and everybody gets to play, but they're all separate. And one thing that's most important for us at Entry Point is that all of these things together give subscribers choice. So telecommunications today kind of requires that we live in the world that whichever provider we have dictates to us. And we're saying there's a better way, let's do things differently. So what does cloud at the edge look like? So here's the VBG, that gateway that sits on the side of your home or in your apartment or wherever you're at. And then we've created FlowOps and SecureOps. So FlowOps is the software that brings all of this together and orchestrates all of these things that happen on the network. SecureOps is what authenticates the physical device and the users as they connect to the system. And then all of that comes together to create what we call the subscriber cloud platform. So how it works. The platform creates a subscriber cloud, and really all that is just a marketplace for SDN things to happen. And it's architected specifically to separate transport from service. We don't want to put those things together and require that whichever transport provider you have to subscribe to their service. We're saying there's a better way, and this can happen using these open networks that people can come onto. So this marketplace does become kind of like your Google Play or your Apple Marketplace, where you can come on and pick things that you want, subscribe to them kind of in an ad hoc or a la carte kind of way, and then you get to choose when and where you use them. So who cares and who benefits? Really, we believe that there's three stakeholders in all of this. There's the network operator, because they're the people that are building the infrastructure to get it out to your home or wherever you're at, your business. They can focus on what they do best, and it does give them other opportunities for additional revenue opportunities. The service provider, it is a new place for people to come. You no longer have to be a carrier or an operator to be able to provide a service. And you can come with whatever great idea you have, and you can access this network and then provide it out to people. And then ultimately, what we believe is most important is that the subscriber on the edge of the network has full control to choose what they want. And it does drive competition, because now the service providers are going to compete on lower costs and better bandwidth and better services, not just because you're captive to their network, you have to subscribe. So we want to demonstrate this. Well, I are going to demonstrate this for you. So this is a video of our system as a whole working together. And on the left-hand side there, you'll see the portal, which is FlowOps, which controls all of this. And this is the subscriber portal. When they come into the network, this is what they're going to see. The window on the right, on the upper side, is the IP address of the PC that's connected to the network. And then the device below is actually the virtual broadband gateway. Let me start this so you can get a better picture. So that gateway, it's got a LAN port, a WAN port on the bottom, you can't see it. And then it's got 4 LAN side ports that the subscriber can connect to. So the PC that is running this is connected to LAN port 1. So when they open up their browser and start this process, just like in a hotel, they get redirected. They're put into a walled garden. They can't go out to anywhere outside of the network because they don't have any services. So they're redirected to the portal. And as a subscriber, they'll have a username and account that they can log in with. I guess I should preface this. What is Ammon, right? Ammon is a small town in Idaho. There's roughly 500 homes, about 14,000 people. And they're building a municipal fiber optic network in their city. And they're distributing that to every resident of the community. And they're doing this open access network that allows people to come on, join, and subscribe to services when they want. The network operator is the city of Ammon, but they're not a carrier on the network specifically. They can be, but they're not working to do that. So this system is running in their network, and their subscribers are able to access this. So they've logged into the portal. On the left-hand side there, you can see that there's a couple categories that we believe are compelling services that can be used in these dynamic open access networks. Distance learning, emergency communication, internet services, IPTV, you name it. It really is a field of dreams, because the network doesn't get in the way of any of these services that are running on the network. And all of this is happening because of NFV and service chaining and Open vSwitch and Open Daylight and OpenFlow, all these things that you guys are doing. This really is the culmination of that in a working product. So it is really cool. So congratulations to all of you guys, and thanks for making my job a little easier. So to subscribe to a service, they just click on the category they want. They can pick from whichever service providers are there, and they just have to pick. Let me pause this again. It's going too fast. Computers. Anyway, they pick the port that they want to subscribe to, so they can have multiple ports running different services. You could even have 2 ports running ISP services, and you can send one to your kids and one to your home, or whatever you want to do. So it really puts you in control. So they would then put in their billing information as they create that agreement with that service provider. And they just click go. And here's where all the work that you guys have done comes in. So at this point, they click subscribe. They get disconnected from the network. You can see on the side over there, they no longer have an IP address. And if you probably can't tell, but the LAN port blinking light is off. So that port is shut down. And at this point, the FlowOps software is going to the network, and it's creating a private network, a layer 2 network from the VBG through the network to the service provider. So we really have taken and given control to the subscriber so they can choose what they want to do when they want to do it. And it creates a private network for them. So there's lots of things that can happen here because it's no longer public internet traffic. It's really traffic that's closed and protected and secure. And we can run lots of other protocols on top of all of this. So now the network is going to be recreated. They're put into another network, which is now the City of Ammon ISP. And you can see that now that CNN.com works. So we're on the internet. So one thing that we've done with them, the people in the City of Ammon, is we've run a speed test to help people see how this really works. So one thing that is compelling for people is when they see how much bandwidth they're actually getting versus what they're paying for. So with the City of Ammon, they're saying we offer a gig, and they can do it. So it's pretty cool. So a town in eastern Idaho is getting gigabit internet speeds, so I'm sure you're all jealous of that, right? Don't move there. We're good with you guys staying right where you're at. One thing that's really cool about this is it is symmetrical, so they can get upload speeds and download speeds that are comparable. So it's pretty compelling what they're doing, and we're really excited to help them enable this service on their network. So once you are subscribed to a service, you can then jump back over to the portal here. Let's get this going. So we can log back into the portal, and to unsubscribe from a service is it's just as easy as when you subscribed. You just click unsubscribe. You say go, and you're now disconnected from the network. You can see our IP address dropped off. The LAN port shuts down on the VBG. A new network is created, and it puts the user back into that walled garden, and they're able to access the portal again. And they can do the exact same thing. They just pick an internet service provider that they want based on price or service or whatever is compelling for them, and they click go. Once again, they're disconnected from the network. A new network is created for them between their VBG and the service provider, and then they're back up and running. And one thing that is important to note is this might seem oversimplified, and maybe that we're just doing some hand-waving in the background, but we're not. It really is that simple, and it just works. And it's really, really cool. So this is another speed test that we can run with this new provider. You can see with a different IP address, we get a different ISP down at the bottom there. And then this provider has a different service level agreement, so there's going to be less bandwidth available. Still pretty compelling at 500 meg. I think we could all live with that, right? And again, it's symmetrical, so it's really cool, and it just works. So not to belabor the point, let's just jump back over here. So that is a demonstration of what we believe is cloud at the edge. So again, I'm grateful for you guys and all the work that you're putting into this. It's allowed us to do some really amazing things. So thank you for your time.
Thank you, Jeff. We have time for questions. If anybody wants to ask a question, please just come up to one of the mics. And
how do the service providers react to it, because it's so easy for the subscriber to change the service?
It depends. The incumbents don't like it a whole lot. But the new guys that are just trying to do things, they love it because it gives them an opportunity to kind of level the playing field so they can get out and provide services that they wouldn't have been able to do otherwise.
are there any more questions for Jeff? We have plenty of time. The talk finished a little ahead of schedule.
Should have talked longer.
You have anything more to say? You could add a few more words if you like.
So just one question. So now debugging becomes harder for the subscriber at home, right? So before they could just log into Linksys, whatever portal, and they could do stuff. So maybe this kind of relates to what we were talking at the beginning, like to provide a lot of debug tools to help subscribers run debugging themselves on the edge, or what do you think? How easy it is to debug then?
One thing that we did in the city of Ammon is we actually opened the doors to the network and invited the people in the community to come in and test drive the network. We had this system up and running for them, and they could do it. And we didn't know what to expect. But we just kind of stepped back and watched people, and they caught on really quick. and they understood. And we even had 60, 70, 80-year-old people that were sitting down doing it on their own, and then they were actually teaching their neighbors how to do it. So they caught the vision really quick, and they were able to do it on their own. So there is going to be a learning curve to this, but we're hoping that as we iterate and work closely with you guys, it'll just become kind of the new norm. Did that answer your question? Okay.
Hi. In terms of service function chaining, so which kind of services do you deploy or do the operator deploy?
We're going to, our primary focus is that the network operator just stay out of the way entirely. So service function chaining could be done by the operator, but we really believe that the service provider is going to be the one that does most of that. And then, I guess, is that the question you're asking? Or
Yeah, but how do you leverage service function chaining today or not?
Yes, we do.
Okay.
So I didn't talk specifically to that, but we can do, an example in the ISP is that the service provider will have a VM running on the VBG, and that becomes their demarcation, their point of presence on that device. And then the subscriber can run OpenWRT, and then we can link those two together on the VBG, so they don't have to have another physical device in their home running their router, and it can all happen on that device on the edge of the home.
Thank you.
I'm curious to know.
Excuse me. All right.
Curious to know what you're running in that little box. Some switch of your own or some services.
It's Open
How do you?
vSwitch. It's Open vSwitch running in Linux.
Okay. Have you thought about adding these kind of services to Mobile Edge?
Yes.
Some more details.
To the mobile phone, is that what you're saying?
In the base station.
Okay, can you repeat your question?
What I see here is for the home broadband access, but there are many initiatives that are going on the Mobile Edge where want to do the edge cloud. In the recent OpenStack Summit, there was also a talk about cloud on the edge. So a cloud on the edge on the subscriber where it is a broadband access is much simpler because you just create some distributed service, you can have some orchestration. But once it goes into a mobile world, you are having a base station that has RF components, and how do we actually move along? So if you have something that you can talk about, you are free to talk. We are open source here.
Sure. So we do, now that I better understand your question. That was the secure ops portion and the TPM. So we recognize that mobility is a huge issue, especially as people move around and you go to your neighbor's house or your grandparents' house or wherever you're moving. We want this to be able to go with you. Even though you don't have to have the physical device, we're able to make it so that you can connect. If you're on the same open access network, you can bring your services with you. So you go to your parents' house or your in-laws' house or wherever you go, you can log in and say, okay, I want to have my IPTV service here with me right now. So you log in, open up your stuff, and it will migrate your service to that VBG wherever you're at. So you can carry your services with you as you go. Is that kind of what you're asking for?
Actually, no. I'm more involved in mobile world where you have the carriers subscribers are like 4G. So 4G terminates in a base station. And there are efforts going on to make that edge run a cloud. So this is more like you can run a component in one place. But when it goes to base station, that's where the actual multi-tenancy gets much more complicated. And you need to provide some hardware that is associated with the base station that will provide similar kind of concept that extends into the mobile networking. So I just wanted to see if you have anything in those areas or thought about it.
Do you understand the question?
May I ask a clarifying question? Are you asking about something similar to what he's described, but with a 4G backhaul instead of a broadband backhaul?
If there is any effort going on where we can have similar service added into a more generic base station, which is not per subscriber, but a bunch of subscribers are actually ending into that.
Okay. So I guess my boss is back here, so I'll kind of defer that question to him. So if you want to catch us, or do you want to answer, Jeff?
So the point
Would you mind coming up to one of the microphones?
And this is Jeff Christensen.
So the intent is the same. We did this work with the University of Utah School of Computing, and they are, over the next year, they're focusing on this issue. So we haven't integrated the two currently, but there's a ton of work, as you know, in the mobile space. And so they're looking at extending this concept into the mobile world. So if your question is, have we solved that problem? No. But conceptually, that is a direction that we're interested in going. Yeah. Does that answer it? Yeah.
I see we have a couple more questions. Is one of them quick?
Yeah, mine's quick.
Okay.
It's kind of two questions, but they're quick ones. One is, do you provide voice services over the box?
It can, yes. So it has a built-in ATA in it.
And you said it has OVS in the box, so what is a data plane? Is a data plane a hardware data plane, a software data plane? Is it DBDK, native?
It's a software data plane. So it's using Open Daylight, OVS, OpenFlow.
And is it the DBDK data plane or the kind of standard OpenVSwitch.ko kernel?
It's the standard, but we are working to extend that to DPDK as well.
Okay, thanks.
And do you have a quick question?
Yes.
Please go ahead then.
So two questions, right? One, can you share the hardware configuration of the box, the device you are using?
Can we share it?
Yeah, what vendor, what box is this?
I'll defer to my boss on that one. So. No culpability here.
Okay. Second, you mentioned the use case of service function chaining, right? Did you guys need to use NSH? There's a lot of noise around NSH, right? Did you feel that you had a use case where you required to use NSH, or was it like you got to do it without NSH?
So NSH, I just was introduced to that today, so I have never heard of that before. Is that your?
Okay. So you did not have to use NSH for service chaining use case?
Mm-mm.
Okay.
But I just was informed about it, so we're going to look into it for sure.
Okay.
Let's thank our speaker.
Thanks.
Okay. Thank you.